Okay, in this video, we are going to derive the unit circle, all the major points on the circle that we're going to use on a regular basis, and then I'm also going to relate this to the ratios that we used in section 1 to define our trig functions, and you're going to see how they're connected. So they're giving us the same value, but we're looking at it from two different perspectives. So we need to think back to our geometry class. If I draw a 30-degree angle and I pull this down, so I'm making a right triangle, and then I do the same thing on this side. So this is also 30 degrees, and I drop this down so it makes the right triangle. So I have two triangles joined together making a bigger triangle. Now, when I look at that bigger triangle, this full angle is 60 degrees. Because this is 90 degrees, this would also have to be 60 degrees. And because this is 90 degrees, this would also have to be 60 degrees to make sure that each individual triangle has 180 degrees total. And then when I step back and look at the big triangle also has 180 degrees because this angle here is 60, this is 60, and this is 60. Now, this is an equilateral triangle when I look at the big triangle. Because all of these angles are 60 degrees. And an equilateral triangle, if you recall, is when all the sides and all the angles are the same. Because this is a unit circle, my radius is 1, which means all my sides have a length of 1. This point right here represents this point right here. And this point right here in purple represents this point right here. So if you notice, the x-axis cuts that triangle in half. So from here to here has to be a distance of 1/2, and here to here has to be a distance of 1/2 because it cuts it in half, and this whole length is 1. So now, if I look at the ordered pairs, I don't know what the value of x is, but my y has to be 1/2 because this distance up here from the x-axis is 1/2. And this ordered pair down here, the y value has to be -1/2 because it's in the fourth quadrant. So now I can use my equation of a circle to find the value of my x when y is 1/2 or -1/2. So I'm going to plug in 1/2 for y, and I'm going to solve this for x. So when I square 1/2, I get 1/4. And now I have to subtract 1/4 from both sides. So I get x squared is equal to 3/4. When I take the square root, I do plus and minus the square root of 3 over 2. Because the square root of 3 is the square root of 3, that doesn't work out even. But I can take the square root of 4, and that comes outside the square root as 2. Because x is plus or minus the square root of 3 over 2, and we're looking at the first and the fourth quadrant here, both of these x's are going to be positive square root of 3 over 2. This one down here as well, so I'll take this out and replace it with the square root of 3 over 2. But if I look at the same place in the other quadrants, that is where you're going to get negative square root of 3 over 2, because in the second and the third quadrant, x is negative. So if I look at the second quadrant, this point right here is going to be negative square root of 3 over 2 and positive 1/2, because in the second quadrant, x is negative and y is positive. When we look at this point here, in the third quadrant, this is going to give us negative square root of 3 over 2 and negative 1/2 for that point. Okay, now I'm going to erase some of this stuff so that I can show you something else. I'm going to erase this. But keep the points on the circle. You don't have to erase. I'm just trying to make room so I can show you this. Now, if I wanted to do the same thing to find the point on the circle where we would sweep open for 60 degrees, I could make the same exact argument using this equilateral triangle. And what would end up happening is I would get this point here to be 1/2 and square root of 3 over 2, where my x's and my y's get switched. So x would be 1/2 and y would be the square root of 3 over 2. And if I find that same point over here, I would get negative 1/2 positive square root of 3 over 2, because now we're in the second quadrant, so x is going to be negative. And then if I come down here and do this point down here, this would be the point negative 1/2 negative square root of 3 over 2, because in the third quadrant, x and y is negative. And then when I find that point that's similar in the fourth quadrant, then that would be positive 1/2 negative square root of 3 over 2, because x is positive and y is negative in the fourth quadrant. So if you notice, we have now found all of the terminal points that corresponds to 30 degrees. So if I open up 30 degrees, and then I open up another 30 degrees to get a total of 60, then I open up and add 30 to 60 and get 90, and I can keep going around, and I would get all the angles by adding 30 degrees repetitively. Now, if you scroll down into the page of your notes where you see your unit circle, all the points we just derived, that's at 30 degrees, the terminal point is the square root of 3 over 2 and 1/2. Using my highlighter, I'm showing you 60 degrees at 1/2 square root of 3 over 2. And then at 120, and then at 150, these are all the angles we just found by using equilateral triangles and the equation of a circle. Now that we derived all of our points, what I want to point out to you now is that if I go back, let me erase this. If I go back to the original triangle that we were looking at before we doubled it and made the equilateral triangle. So I'm looking at this triangle right here that I just highlighted in yellow. This is a right triangle. This is 30 degrees. This side is 1/2. This side, which is my radius, is 1. And then this side here would be the square root of 3 over 2. If I look at my angle of 30 degrees, this would be my opposite side. This would be my adjacent side. And this would be my hypotenuse. So if we now relate this to our trig ratios, if I notice that the sine of 30 degrees is going to be opposite over hypotenuse, if we think back to our trig ratios, and our opposite over hypotenuse is 1/2 over 1, which is 1/2. So if you notice, the sine value is literally just giving us our y value. And the same thing goes for cosine. The cosine would be the adjacent over the hypotenuse. because the hypotenuse is 1, which is our radius, we're really only looking at the y-coordinate or the x-coordinate. So the cosine of my angle is going to be my x value, and the sine of my angle is going to be my y value. So now, if I ask you, looking at the circle and the points that we just derived, here's our angle of 60 degrees, I could ask you, what is the cosine of 60 degrees? So I look to see where my angle sweeps open to 60 degrees. I find that ordered pair, which would be this one right here. Since my cosine of 60 degrees is my x value of that terminal point, my cosine of 60 degrees would be 1/2. So now we can evaluate our trig functions by looking at the unit circle. If I asked you to find the sine of 60 degrees, I would look to see where my angle opens up or sweeps open to 60 degrees, and that would be my corresponding y value. This angle here, let me do it in green now, if I sweep open to 120 degrees, and I asked you, what's the cosine of 120 degrees? The cosine is my x value of that terminal point on the circle, so the cosine of 120 degrees would be my x-coordinate, which would be -1/2. Now we're going to look at 45-degree angle. So I'm going to open this up to 45 degrees. And because this is a 90-degree angle, then this would also have to be 45 degrees. And when we have two angles that are the same, then those opposite sides of those angles are going to be the same as well. Since I know that the hypotenuse is 1, this distance from here to here, we'll call it x. Because this distance from here to here has to be the same, I'm also going to call that x, because we have an isosceles triangle where we have two sides that are the same. So where I would normally have the point xy, the x and the y in this case are going to be the same value. So when I plug this in to my equation, x squared plus y squared is equal to 1, I know that these two are going to be the same. So I'm going to call it x squared plus x squared is equal to 1. So I have 2x squared is equal to 1 when I combine like terms. I'm going to divide both sides by 2, and I'm going to solve for x. When I square root both sides, I get plus or minus the square root of 1/2, which when I rationalize that and multiply the top and the bottom by the square root of 2, I get plus or minus the square root of 2 over 2. So this distance here, from here to here, is the square root of 2 over 2, which means this distance here also has to be the square root of 2 over 2. So I know that that is my ordered pair on the circle when my angle sweeps out to 45 degrees. I can make that same argument over here for this 45-degree angle. So I know that this would be negative square root of 2 over 2 and square root of 2 over 2. Negative because it's in the second quadrant. My x value has to be negative. And when I make that same argument down here with the 45-degree angle, this would have to be negative square root of 2 over 2 and negative square root of 2 over 2 because this is in the third quadrant where both x and y are negative. And then when I do the same thing for this 45-degree angle, this would have to be the square root of 2 over 2, negative square root of 2 over 2 in the fourth quadrant because y is negative in the fourth quadrant. And if we scroll down and look to our unit circle, those are all the values that are in red. All my 45-degree angles. Everything follows from the first quadrant. It repeats all the way around the circle. The only thing that changes are the signs because it depends on what quadrant you're in. Your x and your y might change signs. But quadrant 1 is the same as quadrant 2 because the circle is symmetric. It's going to continue to repeat all the way around the circle. Now, to fill out this chart, I'm going to do the first few for you to show you how to do this, and then I'm going to let you fill out the rest yourself. I'm sure that there's somewhere online or in your textbook that has all these answers. You can check them, or you can check them on your calculator to make sure that they're correct. Okay, so we said, let's make a note up here to remind ourselves, the sine of an angle is going to be the y value, and then your cosine of the angle is going to be your x value of that ordered pair where the angle sweeps out. We're going to use the unit circle on the next page of the notes because we've already derived all those values. So at 0 degrees, that would be 0 radians. And if you look at that circle on the next page, the sine of 0 degrees, or if it's in 0 radians, the sine is my y value. And if you look at that, the ordered pair at 0 degrees would be 0. The cosine at 0 degrees would be 1. Now, using our understanding of the trig ratios, I know my reciprocal identities. And I know that cosecant and sine are reciprocals. So if I take 1 over 0, because sine is 0, and if I take the reciprocal, that's going to give me that it's undefined. So cosecant at 0 degrees is undefined. Secant is the reciprocal of cosine, and if I take the reciprocal of cosine at 0 degrees, that's 1. The reciprocal of 1 is just 1. The tangent is the value of sine over cosine. So if I take 0 over 1, that's going to give me 0. Cotangent is the cosine over sine. My cosine is 1, my sine is 0, so that's going to be 1 over 0, which is undefined because we can't divide by 0. So using the fact that sine is your y value and cosine is your x value, and you can look those up on the circle, we've already derived them, so we know where all those values are coming from. And then we use our reciprocal identities to find the values of the other trig functions. So for 30 degrees, if you look at your unit circle, I'm going to scroll down. At 30 degrees, that's right here, I'm highlighting it in yellow. That's the ordered pair, square root of 3 over 2 and 1/2. So my x value at 30 degrees is the square root of 3 over 2, and my y value is 1/2. In radians, that would be pi over 6. That's labeled on the circle, but you know how to convert it, right? We would multiply by pi over 180, and we would get pi over 6. Then I use my reciprocal identities to find the values of the other 4 trig functions. The cosecant is the reciprocal of sine. So in this case, sine is 1/2. So if I flip it upside down, that's going to give me 2. Secant is the reciprocal of cosine. So I'm going to take and flip cosine upside down, which is 2 square roots of 3. If you want to rationalize it, you can, but I'm not going to in this chart. Tangent is the sine over cosine. So I would take the value of sine, which is 1/2, and the value of cosine, which is 3, the square root of 3 over 2, and I would divide. So when I take 1/2 divided by the square root of 3 over 2, I'm going to get 1 over the square root of 3, and if you would like, you can rationalize it, but I'm not going to. The cotangent is the reciprocal of tangent, which is the square root of 3 over 1, or the cotangent, the other way you could look at it, is that the cotangent is cosine over sine, which would still give you the square root of 3. So just use your identities to find these, and use the circle to find your x and y values. So cosine is x, sine is y. Let's do one where there are negative values. So let's do 135. At 135, if I scroll down, I'll highlight that in purple. That's right here. My radians, if you can see, I just kind of colored over it. It's 3 pi over 4. And the ordered pair is negative square root of 2 over 2 and positive square root of 2 over 2. So when I fill this out for 135, I'm going to have 3 pi over 4 for my radians. And even though it's on the unit circle, we know how to do that. I would multiply by pi over 180 to get 3 pi over 4. My y value is the square root of 2 over 2. My x value, which is cosine, is negative square root of 2 over 2. Now, cosecant is the reciprocal of sine. So I would just flip this upside down. So I take the sine, the value of sine, which is the square root of 2 over 2, and I flip it upside down. Secant is the reciprocal of cosine, so that's going to be negative 2 over the square root of 2. When you reciprocate something, the sign stays the same. So if it's negative and you take the reciprocal, it should still be negative. Tangent is the value of sine over cosine. So if I take the value of sine over the value of cosine, they're the same exact value except one's positive and one's negative. So when I divide, that's going to give me a negative 1. Cotangent is the reciprocal of tangent, or you could look at it as cotangent is the value of cosine over sine. Either way, you're going to get negative 1. So what I would like you guys to do, now that I've gone through a couple of rows with you, is derive the rest of these, and you can check it either online or from your book or on your calculator.